This lesson looks at two examples of finding all angle values. So here's an example. Sine theta is root 2 over 2, and we want to find all the possible values of theta between 0 and 360 so that this is true. So normally, in the past, before we had this coordinate grid idea of angles greater than 90, we had just basic triangles rooted in the applications, where essentially you would just take sine inverse and you would have the answer to theta. So you may remember doing that. However, because theta can be greater than 90, this angle, we have to consider the reference angles. So what you are finding when you take the inverse of sine is a reference angle. It's one of these triangle angles in the coordinate grid. However, your actual angle theta could be this one, or this one, or all the way around, or all the way around, right? So you have all these possibilities. So we need to figure out which one works. We need to figure out what the angle is, and then we need to figure out what it is from 0. So first step is to figure out a reference angle. Another first step could also be to figure out which quadrants it's in. Both of those steps you can do. It doesn't matter what order. So the sign here is positive. What does that tell us? Well, according to our cast development, we know that all ratios are positive here. Sine ratios are all positive here. So it's either one of those two. These are out. So it's either here or here in terms of the angles between 0 and 360. But we need to know what those angles are. So a reference angle, if this is some random decimal, you can just do sine inverse of the random decimal to find the reference angle. However, this is not some random decimal. It's indeed something that you should be able to recognize as an exact value option. So remember your special triangle that had root 2 in it? It was half a square. Root 2, 1, 1, 45, 45. That's your special triangle. You also should see that this, when not rationalized, you can reverse it by multiplying it back again. You'll see that this was actually 1 over root 2 before the rationalization of the denominator occurred, which implies that theta's reference angle is 45, coming from opposite over hypotenuse. So since our reference angle is 45, and you'll notice that if you used your calculator, it might be a little off from that, but this gives us the exact value. The 45 will be this part and this part. But we need the angle. The first angle in quadrant 1 will be 45 degrees, so that one works. But the next angle will be in quadrant 2, and you have to figure out how to figure that angle out. So if this is 45, then you need to take 180 minus 45 to find the other angle, which will be 135 degrees. Notice that if theta was not restricted to 0 to 360, you'd have all the coterminal angles that end in these positions as well. So if that restriction was not given, then you would say 45 plus n times 360, which gives all the coterminals for that, and 135 plus n times 360, which gives all coterminals for that. So that's if that restriction was not there, n is any integer. Let's try another one. So again, we have this restriction, that's fine. So we need a reference angle, we need to figure out which quadrants it's in. So the quadrants, according to cast, where is tan negative? Well, tan is positive here and here, so it's negative here and here. So we have this option and this option. So this angle and this angle will be our final answers for 0 to 360. But we need to figure out the reference angles. The reference angles being in green. Again, if this was some random decimal, you could take tan inverse of root 3 and you'd find your reference angle. But we can use our special triangle to find the exact value. We know that root 3 is part of the 60, 30, 90 triangle, and that's our triangle. So, tan of which angle gives you root 3 over 1? Well, tan, to be opposite for root 3, adjacent to be 1, would be 60. So that implies that your reference angle is 60 degrees. However, 60 is not part of our answer because 60 would result in a positive answer, but we need the negative answer. So the negative answer is here and here. So if that green bit is 60, what are the red bits? So in quadrant 2, the angle is going to be 180 minus 60, which is 120. And in quadrant 4, it's going to be 360 minus 60, which is 300. So those two angles are the angles in that range. Again, if you wanted to have them out of the range, you'd have to find the coterminals to that.